This is the second part of fitting XPS data using KherveFitting. So in the first part, we have fitted carbon 1s. Carbon 1s with 3 picks, when we had a pick that was a pick width of 1.6, and then in the second one, we had a pick of 1.3, and that allows us to see a fourth pick. Okay, and then from this, we can build a pick library or a pick table. So right now, if I'm using again my tab key on the keyboard to switch between picks and then move them, and I can just refit them to put them, you can see that they are not constrained with each other. Okay, so I'm just going to refit again to put it properly. And in here, I have a split column that shows that actually this second pick is around 1.43, then 2.66, and then 3.97. So what that shows is the split between the main pick. And you can constrain them all. If you right click on the green row, you have a propagate column. So if you go on the non-green row, you cannot propagate. Yeah, you have to be in the propagate in a constrained column to propagate. So if you propagate to column, that's going to propagate all those picks to column A. And so I'm going to do it now. And as you can see, it's done in function of A. And if I would have chosen the propagate of the constraint on B, that will have propagate all the other picks to B. And you can also do that manually. So now if I just remove everything and then get the default value, I can also type A here, and that will straight look for the value that is in the split column and put that to A plus 1.43, because this is the default thinking that this is what you want to do in the position. When you just put A, you actually want the constraint to pick A in terms of position. So now what that allows me is that I can move all those picks and they all come together. They are not constrained by area, so that's why they are not moving down, but they are simply constrained by pick position. Okay, and then from this, I can then save this pick table if I'm happy with, and I would tend to actually change all this to something a bit more generic. So, for example, usually I would say that the normal value for CO is around 1.2, and it can go up to 1.5, I would say. So that's why now here I will add something around plus minus 0.2. And then those two picks are actually changing quite a lot. So I would tend to change this one to around 3, and then plus minus something like 0.4. And then this one very similar, where I will put something like 3.8, and then plus minus 0.5. So I think this is a more generic pick table. And this is kind of the same type of pick table Mark Bissinger has made in his website. And again, I will go into help, knowledge, and into XPS fitting Mark Bissinger, and I will just bring that down so you can see what I'll be looking for. Maybe I'll put it here so you can sort of see the two things. So if I go into carbon, then you're going into this pick, all those species, but at the bottom there is a pick table that was done for those 4 picks. So he's found that it should be for himself, he found that it's 1.5. Well, this will get to it, but with the plus minus. And then the C double bono around 3, yes, that's what we have. And then the OC double bono is around 4.15, and that will also do it. Okay, so this now, once you have it, you can save this pick table into the library. into this library, and then you can go into Pix library, and this Pix library already is filled up, and you can add some, but at the moment there were 2 pick tables available for the carbon 1s, which was the C-C with 3 picks, and using the void function this time, and 4 picks using also the void function. So in this case we've done the C-C 4 picks using an SGL function. So if we wanted to redo this pick library using the best method, the void function, then we could, yes, use the pick library that we have available here. So let's remove all of them and open the pick library and go into the CC4 picks. And now I have, obviously the intensity was slightly different, and maybe this is not done to the way you would have liked, or we've just discussed, so I'll just change that quickly. We had around 3 plus minus 0.4, and maybe 4 plus minus 0.5. So something like this. And now you will see that they all come together, the same thing. And we can just put them all to, or at least one of them bigger, and now let it happen, and you can see that it fits quite well. So this is done with the void now. And the void works differently to SGL, meaning that we cannot change the width. We cannot constrain the width, the main width. The width is actually controlled by the width of the Gaussian and the width of Lorentzian. And in this void, which is actually this one, you can see that it's made in function of the area, because everything is in function of the area, the LG, which is the Lorentzian to Gaussian, and the sigma. And the sigma is usually the width of the Gaussian. So we actually calculate the width of the Lorentzian using the value we get from the LG ratio. So this is done automatically. So in that way we can keep the shape for all those picks the same, and then that is usually the best way to just play with the void. So okay, so that's done like that. And now you can actually fit much quicker your carbon 1s. And once this is done, for example in here we have 284.59, you can use this binding energy correction value and click it, and it will look, you could be into another core level, but it will look for the CC. So if you do that, then you find that it's 0.21 the value, the binding energy correction value, and now this is, we can see that everything has been shifted. The core level of all core levels in the same row has been shifted. In here there is only one row because there is only carbon 1s1, and so that's what we get here. So what I'm saying by that is this is a sample on its own. So this is one sample and that's another sample. So at the moment there is only carbon 1s1. So if I'm going into carbon 1s, then this value is 0 because we've not done it yet. Yeah, I can do it right now, and that will move this one to 2.284.8 if we go, and we found that it's 0.05, and everything has been shifted, the peak has been shifted, and it has been done also for Mn2p, as you can see 0.05, but if I go back to carbon 1s1, this is still at 0.21. Okay, so that will now finish the second part.